MBE and you guys, our partnership with MBE.
Okay, welcome back. Thanks. I'm going to try and stay on time here. Welcome. So this next session is on the all-important topic of the value of the Grand Challenge Scholars Program to employers. It's going to be chaired by Al Romig. He is the Executive Officer of the National Academy of Engineering, our Chief Operating Officer. He's also been a member of the NAE since 2003, and before coming to work here, Al ran Lockheed Martin's Skunk Works. He spent the majority of his career at Sandia National Labs, operated by Lockheed Martin, starting there as a member of the technical staff and moving through a succession of R&D management positions, ultimately becoming Deputy Laboratories Director and Chief Operating Officer. Al will be moderating this session and will be somewhat playing the role of Lockheed Martin because unfortunately Mary Snitch, who's on our agenda, was ill this weekend and couldn't join us. So Al, take it away.
Thank you very much, Randy. Yes, unfortunately, Mary was grounded by her physician, so I get to come out of retirement for Lockheed just for a few moments here if there are any questions that are relevant. But that being said, I think we have an outstanding panel here. We have Al Bunshaft from Dassault, Cleo Caboose from Honeywell, and Mike Ritchie from Boeing. There is a heavy aerospace influence there. I wonder how that happened. But anyhow, what I've asked them each to do is share a little bit about themselves and then talk about their organization and what the grand challenges mean to them and how they're trying to capitalize on that in terms of the talent base to run their company. So with that, we'll take about half of our time going through their material, and then it'll leave about the second half to have Q&A amongst ourselves, then also obviously within the panel. So with that, Al, I'll turn it over to you.
Thank you very much. Hello, everyone. Very happy to be here today. I want to take just a couple minutes and introduce to you Dassault Systems, but in the context of why are we so interested and focus on this program. So I'm responsible for all of our activities in academia and education in the Americas. I also coordinate our involvement in the National Manufacturing Institutes, for example, and I run our US-based foundation, which is focused on funding innovative work in education and research that leverages 3D technologies. So Dassault Systems is a global company. We're 15,000 employees around the world. Our clients, we think, are the leaders in innovation around the world across 12 industries that we focus on. But I wanted to show this chart to talk more about where we've been and where we're going. We came in 1981 out of an aviation and defense company, Dassault Aviation. So we're 37 years old now. And it's fair to say we spent 30 years of our history focusing on product and the digital tools needed to design, develop, and manufacture and deliver primarily mechanical engineering type products to the world. And so we started heavily in what I call planes, trains, and automobiles, heavy industry, heavy mechanical engineering type industries. But as you can see, and you can almost look at this chart chronologically from the top to the bottom, we're starting to move into some very different industries over the last 10 years or so. Just to give you two examples, we have a project which you can easily find out more about. It's called the Living Heart. It's the first completely digital model of the human heart, a physical model, including the material science of the muscle tissue of the heart, a fluid dynamics model, an electrical model. It's a collaboration across 26 countries, over 100 researchers and clinical cardiologists. It involves the FDA and the Med Device Manufacturers Association. It's all about understanding and streamlining the approval process for implanted devices in our heart. Now you can imagine that yes, it leverages our modeling and simulation expertise, but it's a very different problem set with a very different type of collaboration required to drive that. As just another quick example, Virtual Singapore. Again, taking our modeling and simulation expertise, working with the country of Singapore to develop a complete digital model of the entire infrastructure of the city/country. They're using it to understand and make decisions about development projects, about public policy, about emergency access, pedestrian crossways, rainwater runoff, above and below the ground. So you can see that we're moving in completely new directions. And in 2011, our CEO and vice chairman changed the mission, if you will, purpose statement of our company to this. And it says that we provide businesses and people with 3D experience universes to imagine sustainable innovations capable of harmonizing product, nature, and life. And it's a bit of a mouthful, but those last three words are very, very crucial and in fact linked to exactly what you're doing here in these Grand Challenge projects that you're working on. We recognize that even in our traditional markets, the products that our clients develop live in the world that we all and the society that we're all part of. We've gotten tremendous recognition for the work we've been doing. We were named at Davos this year as the #1 most sustainable corporation in the world by the Corporate Knights. We're on Forbes number 30 on Forbes list of 100 top digital companies, number 28 on the Future 50. We've been for many years running on the most innovative company list. So these are some of the reasons and the background for why we're moving in the direction that we're moving. Next, I want to talk about something that hopefully most of you picked up, and it's this brochure that was outside. I went outside to get one for myself, and there were only a handful left, so I think most of you did pick it up. So thank you for that. But this is a survey we've done now 4 times, every other year. We plan to do it again next year, and it measures the sentiment excuse me, of students to work on the kinds of problems that the Grand Challenges pose to them. And you can see the trends that we've seen from 2011 when we started this to 2017 last year. Again, we'll do it again next year. You can see the geographic differences in terms of what students consider the most important problems to focus on. And we can start to see some uptick in terms of student interest. It was strong in the beginning, and it's getting stronger in terms of where this is going, in terms of students' desire to work on these kinds of problems. Why do we care about this? Because we need employees that care about this. If this is our agenda, then we need to be able to hire students that have this mindset, that understand that engineering is much more than differential equations and mechanical designs, for example. It's essential and important. I'm an engineer and computer scientist. And also our clients need these kinds of skills and these kinds of people. I've been involved for a good 10 years now in a number of STEM activities. We've seen that the traditional educational system does not, we believe, enrich students with the broad set of skills needed to work on this type of an agenda. And so we're very supportive of working between employers and educators, creating experiential learning opportunities, working on real-world, unstructured problems. We hire over 200 interns a year just here in the United States, as an example, and we try to engage them and leverage them in these kinds of activities. So that's a little bit of background, Al, and happy to be here again.
Great.
Thank you.
Thank you, Al. Okay, we'll move on to Cleo and hear about Honeywell and their interest in the Grand Challenge.
Okay. I don't know if I have the control or somebody else. I don't? Okay. So, good afternoon. Very happy to be here. Very impressive presentation of Dassault as a company, which we are a customer of course. Honeywell, it's a little bit on the other side. Honeywell, it's about 130 years old company. And it started with environmental controls and the thermostat that many of you who live in the United States in particular probably have or had in your homes. I personally have been in Honeywell for 23 years, and for more than half of this period, I've been vice president for engineering in one of Honeywell divisions. And I had thousands of engineers reporting to me, and I hired hundreds and thousands of engineers across the entire world. At times, I had 60 different sites around the world under my responsibility. I'm saying that not to brag, but just to show that I've been faced with hiring the right skill of engineering for a long time and having to find these skills everywhere in the world, wherever I could find them. So I've been faced with the issues of what the engineers can or cannot do when they come out of university every single day, and it's been hard. I had at times positions that have been open for 6 months to a year. I had to close them to reopen in other parts of the world because I couldn't find a system engineer with the right understanding of what system engineering is. At the same time, every time that I was trying to get an engineering in a leadership position, it's been a struggle because engineers come out of the university trained to be just engineers, but without necessarily the leadership skill, understanding the social environment, understanding everything that comes with leading an organization and building the roadmap of technology for a company such as Honeywell or any of the companies that we have here. So that's why when I joined the National Academy of Engineering last year, I very quickly became passionate around the topic because I face it and I see that we need to do something, and we need to do something in the United States and around the world. I'm fortunate to be working for Honeywell because a very simple way that I describe Honeywell is I think Honeywell is on the side of the angels in terms of trying to work for what is good in the world, trying to work for sustainability, trying to work for the number of things that we value here and we list in the challenges for engineering. A couple of additional words about Honeywell. It's a very large multinational, $35 billion about in revenue after 2 divestitures, 2 spin-offs actually. We used to be a $40 billion company, about 130,000 employees around the world, and 4 major business groups in an enormously diversified company. We do from anything from airplane cockpit. I think we produce 30% of any jetliner that you fly around the world, and important systems such as ground proximity, collision avoidance, landing systems. As I said, the entire cockpit of the Boeing 777 is being designed by Honeywell. A number of other systems that protect us every day when we fly. Another business of ours is of building technologies, which is building control, environmental control, access, security, fire protection. So I became addicted to every time I go into a building to look which fire system is there, if I should be feeling safe or not. Then we have another business which is called Performance Materials and Technology. Essentially, it's serving the oil and gas industry around the world. Some of the largest refineries in the world are automated and controlled with Honeywell systems, but also lately moving away from oil and into biofuels and into renewable energy and solar energies, technologies supporting that. And last but not least is the safety and productivity solutions, which provides safety for workers around the world. And we produce everything from rubber gloves that your utility linemen use to fix a power line, to footwear, and to very sophisticated system for firefighters. So we are definitely a conglomerate. And as I said, we invent and manufacture. We are a manufacturer still. We have a lot of factories around the world and address some of the world's most critical challenges. So our business object is to address those challenges around energy, around safety, around security, around productivity, around global urbanization. So we are deeply involved in all of this. Lately, over the last 5 to 10 years, we became very engaged into the connected system and the connected solutions. And we moved from providing, let's say, sensors or thermostat or so, to providing connected factories, connected building, connected aircraft. I mean, many of you who enjoy having a Wi-Fi connection in airplane over the Atlantic, it might be probably a Honeywell system that provides the Wi-Fi connectivity there. And it's going to be expanded massively in the coming years. So connectivity, it's a big topic for us, and we try to make the world safer, more comfortable, more productive by providing this connected solution. We are looking at enhancing the quality of life. We do the environmental control, the air quality control. We had a big contribution in China to provide clean air in the building when China was at the top of the air pollution, with air 2.5 particulate matter in the air. We try to improve the quality of people around the globe. And last but not least, joining the other probably corporate organization, social responsibility, it's something that our investors ask of us all the time. And so our giving arm, our corporate charity arm, which is called Honeywell Hometown Solution, has a couple of areas which is focused their effort, our donation and our work, and that is environmental impact and social impact. We have very strong programs in STEM, in education, in smart cities around the globe, in safety education for children around the globe, like to prevent abduction, to prevent a lot of horrific things that can happen to children. As I said, in order to do everything that I was just mentioning, oh, my time is up. Wow. I was told I have a little bit more time than I thought, but so I'll go quickly through that. I already mentioned. So we see an evolution in our company from device to system, from team to partner ecosystem. We used to do everything in-house and we were very proud of it. Today, I am working with like 20 partners, startup or large company, to bring the technologies that I need into the company. You need different people to deal with this situation, from physical to digital, from technical astute to socially responsible. And on the right, you see the kind of skills that we need: multidisciplinary, system-level thinking, digital foundation, beyond technical, understanding the end user when you try to provide solutions, because the solutions are specific to the user, are not like, you design a pressure sensor. You don't care where it goes a little bit because it's a pressure sensor. Now you give the final solution to the user. Multicultural skills and social responsibility. One of the things that I definitely want to mention, and I see the red lamp blinking there, what we have done as a company, we found the need of connectivity between the students and between the campuses. And we created a pilot program, which is called the Connected Campus 4.0, obviously related to Industry 4.0. We went to Indonesia, of all places. And in one of the institutes in Indonesia, we created a mini refinery, the controls for a plant. In another university, we created a mini building with all the controls associated with the building. In another university, we put software, sophisticated software, to do analysis of the data and simulation, like cities and buildings and refineries and so on. We provided cloud connectivity, and students work between the campuses, use data from the mini refinery into the simulation and from the building and so on. We are extending the program now to Romania, and on November 7, I'm going to be in Romania, where we're opening there the first campus. I think the Grand Challenges program has to align with companies like ours to leverage the resources, to leverage the vision, and together to be more powerful. Thank you.
Good afternoon. I'm Mike Ritchie. I'm from Boeing, out of corporate. I'm in Seattle, Washington. I'm a chief learning scientist there, and I'm in their fellowship, and I'm studying knowledge management, knowledge flow across our network, and specifically engineering. So who we are. So we're the largest aerospace company, largest exporter. We assemble commercial and defense products. Last year, 2017, we were a $93.4 billion industry with a footprint in 150 countries. We have a manufacturing supply chain that consists of over 20,000 contracts with suppliers across the world. We're about 140,000, 142, but we're moving up. Lots of open requisitions out there right now. And we're in 65 countries, and our tagline is really to connect, protect, explore, and to inspire. So a quick note on the NAE challenge as far as advancing personalized learning. This is one of the things that we've anchored some of our internal research to, and some of the programs that we've built around the GCSP program. And we're actually quite aligned to this, and we're trying to build a team inside of Boeing that would help get us there as far as the neuroscientists, the statisticians, and digital designers, and learning scientists, and folks that can help us map the competencies that we require as we move into this new fourth industrial revolution. And so speaking of that, you can see in this chart where we're really focused on the future of jobs out of the World Economic Forum. It was mentioned a little earlier about increasing adoption of technology, advancements in mobile and internet technologies, and artificial intelligence, and then really collecting the digital exhaust that's on the human and machine and sensor side across advanced production systems. And so to capture that digital exhaust and to optimize that to help with our production systems, it requires us some shifts in thinking, and from systems engineering to model-based digital twin kind of engineering, and we're partnered with Dassault on that program. Additive manufacturing, we just released a new program out of MIT on additive manufacturing that's online that we've instrumented, and we're looking at upscaling all 140,000 people across the company in one topic. We've got intelligent cognitive tutors that we're looking at that sit on top of the learning environment, look at the trajectories and proficiencies of the learners, and then recommend topics and lectures and content that they might not have. All of this is in context of this GCSP goal on shifting mindsets and this notion of a T-shaped individual, somebody that has broad experiential knowledge and can connect and collaborate and optimize, but they have deep technical knowledge. And so this is right in line with the GCSP program. You can see here some of the skills that we're trying to build, not just in modern, and open human and machine systems, which we're moving to, but also in the traditional upskilling of incumbent engineers, production, software engineering, model-based systems, things of that nature. And then on these new skills that are kind of emerging with big data and cybersecurity, especially for advanced human-machine robotic lines, and then some type of infrastructure for blockchain and data that would help us with protecting the production systems and the human-machine interaction and trust on the floor. So what are we doing? This is one of the things that we're trying to build within Boeing as far as an experience. Somebody had mentioned earlier, let's build something, and that's what we call this. We really want an experiential program for undergraduates. And so right now, we have a design, build, fly 2-semester capstone with the universities that you see here, and you can see the GCSP members right now, the Georgia Tech and Clemson, and we're working on the rest as far as alignment and membership. You can see our Dassault partners, and UCLA is auditing, and we've got this on some learning platform right now. And the basis of this 2-semester capstone is driven from NASA. They're really helping us with defining this 2-semester capstone, meaning that we use their systems engineering gated process during this capstone. We allocate budgets to students. The students have an structured problem that they have to go solve socially. This year, the focus was on Mars 2020 and creating both UAVs and hovercraft that could act as an array of independent platform machines that would interact with one another and then search for things like in situ metals, because you're not going to be able to bring them up there. We want to mine them to look at ice crystal concentrations and methane so that we can extract oxygen and H2O, to look at solar radiation and things of that nature, but really have a mixed fleet vehicle that looks at where we might colonize Mars. So that's what kind of is at the center of this one, but the students have a choice. We do have a stakeholder engagement pattern where they have to go out and talk to the stakeholders. They have to extract, through some kind of TQM or some kind of Pew morphological matrix, the stakeholder requirements against the budget. We've embedded this with some learning scientists. We've got some really good ones on the team that are looking at the clicks and picks and the digital exhaust that's created as far as the students' trajectories and what they consume and their proficiencies. We're introducing new novel manufacturing processes, and we have awards for advanced manufacturing and additive. A couple of years ago, one of the students' teams won the ASMT award for the largest 3D printed UAV, and that thing was fast. So they printed right and left, put the avionics in the middle, and then they did flight demonstration in front of a bunch of Boeing folks. And then we're also looking at the informal aspects of this, meaning the students' engagement with the formal content that's on the university side for their requirements, but also the informal side. So we have a lot of chatter as they're moving through the NASA gated process and they're hitting their KPIs, and they're teaming to optimize against the life cycle of the part. And so we have a lot of interesting chatter that's going on Slack and Matters Most and a couple of the other platforms, and we're trying to meld all that together. We have one community college from last year, and they act as a technical resource for the design teams, and they do all the high-speed machining and manufacturing, and they ship the parts out. So this is basically a microcosm of Boeing, where they have to collaborate, they meet once when they kick off, and they meet during flight demonstration. And so we're trying to get every student, and there's like 85 of students in this right now and 10 faculty, and we're trying to get every student, get each school aligned to the GCSP program, and then have the students graduate as GCSP scholars. And that's it. Oh, last thing we're doing is we put a $10 million gift to the NSF about 3 weeks ago. NSF is matching that gift, so we're starting off with $20 million, and they're ready to write a DCL out of the NSF to actually go out there and build competencies for 21st century engineers, and it includes a bunch of the things I had in the previous slides as far as data structure, mechatronics, robotics, cyber, and all those sorts of things. And they're going to post those, release that DCL, go through their vetted process on awarding the schools that have the most creative proposals, and then they're going to build products. So in about a year and a half, we'll have a bunch of product out there on the web to consume and for courses like Aeropace. And that's it.
So thank you, Al, Cleo, and Mike. You know, this is, the talent, I think you could say, really is the coin of the realm. And in fact, if you look, every place in the world you go, everyone is just hungry for talent. In fact, it's interesting to me, and I think to Dan and the Academy in general, that you know, the Chinese produce more engineers per year than the US, Europe, and Japan combined, and even in China. You know, they're screaming, not enough talent, not enough talent. And what's important with the talent is when you graduate from the university, you already need to have a whole package. You know, you really don't have the luxury to develop some of the competency skills that are coming forth in the Grand Challenge Scholars Program and take the time to develop them once the person is actually on the job. And quite frankly, if you look at the 5 competencies, the first one, the talent one, the research and creativity one, that's the one that has been a long time tradition that all of us, even the older gray-haired ones and not so much hair and hair color and bottle ones in the room here, that was the skill that we all had when we got out of school, and many of the other things then had to be learned along the way. And of course, what the Grand Challenge Scholars Program tries to do is short-circuit that process and cultivate those skills when people are still actually at the university. So I'd like to take the privilege of asking the very first question here of each of you, and that is, if you look at the other 4 competencies, whether it's multiculturalism or multidisciplinary, or the notion of it being a good business, making good business sense, or having some social good, which 1 or 2 are the ones that you think are the most critical that are missing in a lot of the students that are coming out of the universities today that have not been through the Grand Challenge Scholars Program? Anyone?
Go ahead.
Cleo.
So as I said, with the situation with the system engineering, I think at the current time, multidisciplinarity was a very, very important thing that I saw missing, because everything, that's why I insisted on this, the connected system that we play in is like, you can't have just, you know, your narrow trade. It all interacts, and you have to understand the interfaces, and you have to have this broader view. So multidisciplinarity is extremely important. And for our business in particular, also the multiculturalism, the multicultural aspect, because we create products for the entire world, and we work with teams and engineers from the entire world. So people that are sensitive to that are prepared, and that know how to be productive in this environment are extremely important.
I would say that well aligned with my own experiences at Lockheed Martin as well. Engineering is a team sport, especially when you talk about the large systems of the kind that these companies, in fact, build their business portfolio around. So, Mike?
Yeah, I think systems engineering, understanding the system, and if you think of creativity and innovation and multiculturalism and teaming and collaboration, those are all central to this convergent idea, and so especially around systems engineering. So with our aerospace program, we do align it to systems engineering KPIs. So often that's the first time undergraduates get exposure to a gated process where they have to go through a review, and they go through PDR and CDR and manufacturing readiness, and they get approved to move forward. So that's one big one. The second one is they have to manage like this ill-structured environment. So we don't spoon feed them everything. They have to go out and figure this out, and there's a lot of struggles, and the collaborative part of that. And because in this particular case, we have students that have, say, like one team of 10 might have 2 Purdue students and 3 Tuskegee and 2 Georgia Tech students and 2 Brigham Young students, that they have to do this collaboratively over the internet. So they have to optimize and argue their point. It's almost like a baton race. The person with the best knowledge on structures or aero steps up and they lead through that phase. And the person with the best on mechanical, they step up and lead through that design for manufacturability. And so it's really interesting to look at the collaboration and the friction between the teams as they're trying to optimize, but that's exactly what we do. And so providing an undergraduate experience that allows students to have a sense of the life cycle, have ownership for the responsibility, the budget, and the outcome. And it's high stakes, they have to fly this thing in front of a bunch of Boeing people in April. So it's got to get off the ground. And so they have to manage that, and they have to do it in a virtual way. And so I'd say the exposure to the multiple cultures on each university is really solid. The managing within the constraints of the system-gated process is really solid. And it's those kinds of things that we really like to see in the engineers when they come into Boeing.
Good. Al, from Dassault?
Yeah, so I love the comments that you made, and I'll try not to repeat them, but I have to start with working in diverse teams, multicultural teams. I think that's the nature of all of our businesses today, whether your business is centered on the US or whether you're a global business. And in fact, we know from research that we get better solutions when we create diverse teams. So therefore, it's essential that we have those teams. Therefore, it's essential we have to be able to work in those teams. So I think that leads the way for me. Interdisciplinarity, I intentionally used a couple of examples at the beginning that are by their nature interdisciplinary, but again, I think the most interesting and far-reaching research we see going on today is often multidisciplinary. So I think it's essential that we understand how to think that way and understand how to leverage others. I think one of the I was involved in a lot of research around STEM skills, and whether you call them employability skills or professional skills, or the term I hate, soft skills, one of the ones that we often forget to put in the list is listening. And when we work in interdisciplinary multicultural teams, and you all here are very, very smart people, so you're used to sitting there thinking about what you're going to offer next and what you're going to contribute next, and sometimes we forget that our job is to be listening when other people are speaking. I'll just add 2 more. Complex systems of systems. So systems engineering, absolutely. If you look at the systems that any of these companies or others build, it's often very highly complex systems of systems, and we now have the tools to be able to model and simulate completely those complex, often cyber-physical systems. And the last one I'll say from our point of view is bringing modeling and simulation expertise to new domains. There's a lot of industries that are ripe for digitalization. It's going to happen, and the kind of skills we need to develop as a community here are what's going to drive that. So,
good. So with that, why don't we, Randy, go ahead and start running the mics, and we'll open it up to the audience for questions and comments.
Hi, Kenny Scheffler from the University of Idaho. I have a question as a graduating student, as a Grand Challenge Scholar. What's some advice you guys can share for marketing ourselves as Grand Challenge Scholars? In an interview, what does the company look for when specifically interviewing Grand Challenge Scholars?
Anybody?
I can start. I know with our talent management folks, we're talking to them about using the Grand Challenge Scholar acceptance letter, your completion as an indicator for somebody that's ready to go to work, to put some market value behind that. And I think that that's something all industry could probably work together to do. So if you have that, that's just another, really good indicator that you're going to hit the ground and you're going to be more productive because you've been exposed to these concepts that we're clamoring for. So I think that there's some work to be done in industry to show the value of that completion. But our president said it best. I think Dan Moat said yesterday, he was banging on the table saying all of our engineers should have this, and he's right. And so I would put that right up front, in your resume, and I would say, that the experience that you gained from touching on those mindsets, weave that into the narrative of your resume. And when they do that spider search, and there's 2 million folks applying for, 1,000 jobs, that those things will surface up because we put keywords in there to kind of look and see if people's had these kinds of experiences.
Actually, I wanted to comment even from the previous panel, but knowing that I will be here, I didn't comment there, is I believe that we have to expand the Grand Challenges Scholar Program not only to universities, but to industry as well, to have partners, industrial partners that are part of the network. Because if you look what you told about Boeing and your engagement with so many universities, what we are doing, we are doing the work already to engage with universities, to create these connected campuses, to create the kind of students. And it would be fantastic for us to get officially, so to speak, part of the network, and then for this to be part of our hiring process, So the Grand Challenges student, they would know that the companies that are part of the Grand Challenges network certainly understand what they did, where they worked, and would evaluate their program very much.
Just to share one thing that's in our thinking, and Rama might have said this earlier, but we've started working with a few national laboratories, putting internship programs, and the next step beyond that will be doing it with industry. So we'd like to get it engaged even at that sort of student level and give you a chance to see whether or not there's really some fire behind the smoke that's on the letter that says they completed the program. Al?
What comes to my mind is very practical, and I hope you all realize it, but you just heard 3 employers say what we value in this program. I recommend turn it around on us. And by the way, any company you want to work for as a Grand Challenge Scholar is going to value those things, or probably you don't want to work for them. So I think you need to turn it around and say the things I learned are these things, right? How to work in a complex, multicultural, interdisciplinary team, et cetera, because we know that's what we need. Showing your understanding of the bigger picture of engineering is what will differentiate you, I think, from other students.
Right. Other questions? See a hand.
So I'm Michelle DeCroix from Los Alamos National Lab, and we are a lab looking for Grand Challenge Scholars to apply to our student program. My question, though, has to do with retention. So we find that we can get some really excited people in the door, but we've got to retain them, and I'm wondering if you've changed your performance management aspects, raises, and how you evaluate employees to incorporate more multidisciplinary team success versus individual success.
I can say that for software engineers, many companies are creating special path, the multipliers or whatever the word of the day is, to show people that can have an outsized kind of contribution to the companies through their capacity. I think if we get with the industry in general to be part of this Grand Challenges program, we could arrive at engineers that are other than software maybe, to make this Grand Challenges preparation, to make them stand out from the crowd and be rated from the very beginning of their employment, as somebody that is ready for a leadership position. We used to have pathway students that were in their top of the class in some of the universities, and then as they come into the company, we would deliberately give them like 6 months or assignment in different departments so that very quickly they become a rounded person, understanding the business processes, understanding the challenges in the company. So I can imagine where with Grand Challenges scholars, we could talk to the companies to create the same, like a pathway program where they will come and move from department to department with different type of jobs. So in 3 years, you become a very experienced, person ready to take on a more major job.
Yeah, I think from our perspective, if you look at the functions, you can imagine an airplane that just the flight science folks designed, or just the mechanical engineering or production engineering folks design, or the software engineers design. You could imagine that. So we have integrated product teams, and then we have accelerated work that's kind of the narrative glue that goes across the functions. But on the university side, you don't really see that. They're still in the function largely, with some opportunities for some capstone and some opportunities to get these skills. But what the GCSP represents to me is an opportunity to frame that at the university, to build those skills prior to coming into the workplace. And for us, that's a pretty big deal. We did a study a couple of years ago on the 3+2 schools, and we looked at how they ramped through Boeing, how fast they moved up to through their engineering levels. And the 3+2 schools just outperformed everybody else. And it was because they had some of these principles embedded inside of them. They weren't as functional. So I think the talent question that you surfaced, it's going to be, we're going to have to deal with that. It's emergent. The landscape is changing. If you look at the fourth industrial revolution and what it's going to do with data science and advanced production systems, the skills that are going to be required for incumbent and new engineers are changing. So everything's hitting at once. So I think that that's going to have to be part of it, the talent management strategy to keep people.
Okay, I see we're down to our last 10 seconds. Unless you want to let me run a minute longer, Randy.
Hi, so I'm Sarah. I'm from Clemson University. In addition to being a Grand Challenge Scholar, I'm also the peer advisor for the Global Engagement Office for Engineering. And the biggest question I get asked in that position is about international internship opportunities in industry. And I was just wondering if your company's had any that you can talk about.
Anyone?
I'm not aware, actually, of international internship opportunities directly because of some of the application processes, visa requirements, et cetera. I know I've been involved trying to execute those, and it's difficult to often execute the required documents in time to host the student overseas. It's certainly true in our headquarters in France, I know. So I think it's a great idea. It's something we need to facilitate more of. We certainly have intern students that work on global projects and work with global teams and therefore get global and multicultural experience. But hiring an intern in one country and then placing him in another country, I'll just be very direct, I'm not familiar with that.
Yeah, and last year, Boeing had 1,600 interns that they hired. So I'm going to take your question back to our talent management folks, and I'm going to look to see if there's a way that we can use that as a signal, to cut through all the noise that you see on the hiring process. But I think that would be just, if we could get GCSP scholars to come into our internship projects, I think that would be a big win.
Good. Well, let me close this session just with a request to you, and that is, early on, Rama mentioned some of the metrics that we look at now. They're the ones that are easy to measure: how many schools, how many students, how many graduates, et cetera. But at the end of the day, what's going to be important is what difference did it make when these people with these sets of skills hit the ground running after they've been there for 10 or 15 years. So as we try to track and formulate these longer-term strategic metrics, we'll need to partner with industry where you can give us the feedback that tells us, yes, this made a difference really, and this is something maybe that needs to be modified to make it even better going into the future. So with that, let me close, and let's thank our three panelists.